Welcome. In this lesson, we are going to be talking about two key components of functions, or of a combination of functions, that are important, which builds on the last lesson where we were talking about different properties of graphs of equations or graphs of functions. So we're going to build on that idea a little bit here. And the first thing that we're going to talk about are intercepts. So why are intercepts important? Oftentimes, those points are the most applicative in real-world situations. In later sections, we will talk about extrema, the maximum or the minimum value, and those are also distinct points that are useful in the business world that might have, you may be trying to maximize profit, or you may be trying to minimize cost, and those different key parts of functions that we can think about graphically, those are important pieces of information. So we want to know how to find these different pieces of information because they can help us in an application sense. So let's focus on intercepts. How do we find intercepts algebraically? Well, the X-intercept is just the ordered pair when the y value is equal to 0. So the X-intercept is the ordered pair that we get when y equals 0. So we'll have a number, comma, 0. Depending on the type of function, there could be one of those, there could be two of those, there could be 3 or 4 or none. But that's, to find the X-intercept, what we would do is plug in y equals 0, and then we would solve for x. And we have done this in previous sections when we were talking about linear functions. In the very first section, we talked about finding the x and the y-intercept for that function. Now we're just talking about finding the x and y-intercept for any function. So the y-intercept, how to find that algebraically? The y-intercept, well, we would let x equal 0, and we would be looking for points. 0 equals a number, so plug in x equals 0 and solve for y. This is how we would algebraically find the intercepts using a function. And now it sounds so simple and straightforward, but we actually are going to have to use, if we're talking about a more complicated function, we're going to have to use a lot of things that we've learned in previous courses. Possibly factoring, possibly solving a quadratic, possibly using the quadratic formula. All kinds of different things that we've learned before are going to come back to play in this particular section, or in any section when we're looking at finding the intercepts. Graphically, really what we're doing is we're just looking at the graph to find the intercepts. The x-intercept is the point or points on the x-axis. So we would look for the x-axis and determine where on the graph we are crossing the x-axis. Similarly, for y-intercepts, we're looking for the point or points that are on the y-axis, or that cross the y-axis. Let's go ahead and look at an example here. Let's find the x and the y-intercepts for this function. So I'm going to rewrite this as y equals x to the third minus 4x. And let's go ahead and find the x-intercepts first. That means that we're letting y equal 0. So 0 equals, and I'm going to go ahead and factor out the greatest common factor there. My goal here is to solve for x, and I actually noticed that after I factored out the greatest common factor, this is the difference of squares, so that's going to factor to x plus 2, x minus 2, and if you didn't see that, you might need to review factoring a little bit. And then to solve this, I'm going to set each of these factors equal to 0, and that's going to give me 3 answers, or 3 x values, 0 and plus or minus 2, 3 x values that are x-intercepts, or 3 x values that make the function equal to 0, or 3 ordered pairs that cross the x-axis. And let's actually stop and go ahead and write these as ordered pairs. So if I plugged negative 2 into this function, negative 2 to the third is negative 8, minus 4 times negative 2, so plus 8 equals 0. And I'm hoping that actually you're wondering, why in the world are we plugging these in? They should all be intercepts, right? So they should all be 0, which is true, but let's just confirm that for ourselves. If I plug in 0, 0 to the third minus 4 times 0 is definitely 0. If I plug in positive 2, I'm going to get 8 minus 8, which is also 0. So you don't need to show this work because, yes, these should all be equal to 0 when we plug them in. That's how we set it up. That's how we calculated these x-intercepts. So all 3 of these points are x-intercepts. Now we're going to talk about finding the y-intercept. So the y-intercept, or intercepts, is what we get when x is equal to 0. So if y equals x to the third minus 4x, if x is equal to 0, that means that y equals 0 to the third minus 4 times 0, or y is equal to 0. So there's only one y-intercept, and that's the ordered pair 0, 0. And yes, that is on both lists, and that's okay because it is intersecting the origin. The point 0, 0 does intersect both the x and the y axis. So why is this helpful? I want you to think for a minute. We just found 3 points that are on a graph. So in future sections, if we were going to graph this function, what we could say is we just found the point 0, negative 2, the point 0, 0, the point 2, 0. And what we're going to do in the future is, let's make those points a different color. What we're going to do in the future is say, okay, well, what's happening here? So we can sketch the function. What's happening here? What's happening here? So that we can get an idea of what this function looks at. But starting with our intercepts is going to help us visually understand what's going on with the function. Let's spend some more time finding the intercepts now that we've spent a good amount of time talking about how they're helpful and how to find them. Let's go through some practice problems. So find the intercepts and consider any symmetry for the equation. So what I want you to do, actually, even before you find the intercepts, is I want you to think about what type of functions we're talking about and any other information that you can get. So let me show you what I mean here. Number 1 is a quadratic. Since it has a negative x squared, y equals negative x squared, it's a quadratic function that opens down. It's going to have y-axis symmetry, or it's going to be an even function just based on the way that it's set up. There's a constant, x squared, doesn't change if I plug in a negative value. So these are all things that are just helping me visually understand what's going on with this function, which can help out a lot in future sections. So let's go ahead and find our intercepts now. Let's find our x-intercepts first. So that means that y is going to equal 0, so 0 equals negative x squared plus 9. If I add x squared to both sides, x squared equals 9, so x is going to be plus or minus 3. And if I was to write these as ordered pairs, negative 3, 0, and 3, 0, these are my x-intercepts. And if I was to find my y-intercept, I'm saying that x is equal to 0. So y equals 0 plus 9, or the ordered pair 0, 9 would be my y-intercept. So if I was to talk about end behavior, as I did in other sections, I could say that as x approaches both positive infinity and negative infinity, f of x is approaching negative infinity since it's pointing down in both directions. If I was to talk about the domain, which would be all real numbers here, I'm thinking about the x's. If I was to talk about the range, I'm thinking about the y's, which would be negative infinity up to the y value of this vertex, which would be 9. So I'm just trying to really have you start a problem and think through everything that we know about that function, all the things that we've learned in future classes that are really leading us to this point. Okay, let's look at number 2. So thinking about what type of function is, it's an absolute value function. It is opening up since there's no negative sign in front, like there was a negative sign in front here. This would be an absolute value function that looks something like this, touching the axis here. So again, getting a visual understanding of what this looks like will help us understand what's going on with it. All right, x-intercept is what I get when y equals 0, or when f of x equals 0. So 0 equals the absolute value of x minus 1. So what would make the inside equal 0, since the absolute value of 0 is 0? The only thing that would make the inside portion here be 0 is if x equals 1. So there's an x-intercept at 1, 0. Now we're going to think about y-intercepts, which means that x is equal to 0. That would say that y, or f, I'm going to just call it y equals the absolute value of 0 minus 1, which is going to be 1. So there's a y-intercept at the ordered pair 1, 0, which we'll just say that's here. Thinking about symmetry, there's not x-axis or y-axis symmetry. There's definitely symmetry, and there's going to be symmetry over this line right here, which would be x equals 1. There's definitely symmetry that we could think about and consider. So I want you to take a couple of minutes to look at numbers 3 and 4. See if you can identify what type of equation that is. What would it look like if you graphed it? Then think about how many intercepts would you expect to see, and then go ahead and see if you can calculate those intercepts. If you get stuck, go back to the basics. How do you find the X-intercept? You plug in 0 for Y and see if you can solve. How do you find the Y-intercept? You plug in 0 for X and see if you can solve. So go ahead and pause the video and try and work through numbers 3 and 4. All right, number 3 is a circle. If you remember, this is the basic form of a circle. X squared plus Y squared equals R squared. So this is actually a circle that's centered at 0, 0 that has a radius of 3. Now, did you need to know that fact to find the X and Y intercepts? No, you didn't. But it's good to help you understand. So is this a function? No, it doesn't pass the vertical line test. But we can find the X-intercepts. X squared plus 0 is 9, so X is going to be plus or minus 3. So the X-intercepts, negative 3, 0, and 3, 0. The Y-intercepts, what we get when X is equal to 0. So Y squared is 9, so Y is plus or minus 3, so the Y-intercepts, 0, negative 3, and 0, 3. Now just thinking about this, is there symmetry? Yes, there's symmetry about the X-axis. There's symmetry about the Y-axis, and there's symmetry about the origin. Circles have lots of symmetry. Number 4, whether or not you remember this, is actually a horizontal parabola, not a function, but it would look something like this. Again, you don't need to know that information in order to find the X and Y intercepts, but it's always helpful to start and think about that. This would have X-axis symmetry. So let's go ahead and find the X-intercept. X-intercept means that Y is 0, so 0 equals X minus 4, so our X-intercept is at 4, 0. Our Y-intercept means that X is equal to 0, so negative Y squared equals negative 4, so Y squared is 4, so Y is plus or minus 2. So we have Y-intercepts at 0, negative 2, and 0, positive 2. And that wraps up intercepts, how to calculate them given an equation. What we're going to do next is we're going to look at what happens if we actually have two equations that we're looking at the same time. So let's say we had the graph of a circle, and let's say we had the graph of, let's go simple, a line. When we talk about their intersections, we talk about those points, or 1 point, or more than 2 points, depending on what two things we're talking about, when they cross or when they intersect, and those are called their solutions. Equation-wise, it looks like a system of equations, which you can see down here in number 1 and number 2. That looks like a system of equations that can be solved. But what we're talking about graphically is, where do the two graphs cross? Where do they cross each other? And those solutions are typically written as ordered pairs. What points exist in both functions? How do we find these? Well, we're talking about when these two functions are equal. So what we just do is we set the equations equal to each other and solve. Typically for X, and then plug that X value in to find Y. If we're looking at a graph, you can identify the points from a graph. So, how we're going to end this video is just doing some practice using this idea of solving a system to find the solution to a system of equations. So here we have a line and we have a quadratic. Now thinking about that, if I have a quadratic and I have a line, they could cross twice, they could cross once, or they could not cross at all. So there are different options on what and how those solutions might look, but let's go ahead and mathematically calculate this. So we're going to set this, which is equal to Y. I'm going to substitute that in for Y in this equation. And we did a little bit of this in the linear section, but now we're looking at functions that are more complicated. So x squared equals 3x minus 1. So I'm going to get everything on the same side. So I'm going to subtract 3x and I'm going to add 1 to both sides so that I now have this quadratic equal to 0. This particular quadratic, when I look at it, it doesn't look like it factors. It would be possible to complete the square, and actually that's the method that I would probably go to here, but most people aren't so comfortable with fractions. So I'm going to use the go-to method that always works with a quadratic and standard form. I'm going to use the quadratic formula. So a is the value in front of x squared, which is 1. B is the value in front of x, which is -3, and c is my constant. The quadratic formula, x equals the opposite of b, so 3, plus or minus the square root of b squared, -3 squared, minus 4 times a times c, all over 2a. If you need to review that, there are plenty of videos for you to check out there. So this is going to be 3 plus or minus the square root of 9 minus 4, so 5, all over 2. Now for a messy value like this, I would not ask you to plug this back in and solve for y. I would let you leave your answer as simply the x values. If you had to do that, you could just plug it into the squared equation, which would probably be the best choice since you could get rid of this square rootness. Or you could separate it into 2 different x values and use either of the equations. But for right now, I'm going to let you just leave it here because the point is that you can set the 2 equations equal to each other and solve. So if you're feeling confident in this, go ahead and do that on number 1 and then move on to number 2, see how far you can get. Otherwise, follow along with me in the video. So hopefully you had a chance to do this on your own. I'm going to substitute 2x into this equation. So 2x equals x to the third minus 2x. If I subtract 2x on both sides, I get 0 equals x to the third minus 4x. I'm going to take out x, which leaves me with x squared minus 4. This looks kind of familiar. X plus 2x minus 2. So again, I'm factoring here. So I'm getting 3 x values, 0 and plus or minus 2. To find the y values, you could use either of these 2 equations. I'm going to use the first one. -2 times +2 is -4. -2 times 0 is 0. -2 times +2, 2 times +2 is 4. So these are the 3 solutions. This cubic function crosses with this linear function 3 times at these 3 values. So go ahead and set up number 2, and if you get stuck, unpause the video. All right, so 4 over x equals x plus 3. Now some of you right now are thinking, how in the world do I do this? I have x in the denominator. Well, that's fine. Just multiply both sides by x. X over x is going to be 1, so that leaves us with 4, and this is x squared plus 3x once we distribute. Get everything on the same side. Minus 4. This factors, you could use the quadratic formula, but this is going to factor x plus 4, x minus 1, which is going to give us x values -4 and 1. So if I plug -4 into this equation I have boxed, 4 divided by -4 is going to be -1, and 4 divided by 1 is going to be 4. So those are the 2 points at which these functions intersect. All right, let's recap what we covered in this video. Intercepts, a function and its intercepts, are the points in which the function crosses the x or y axis. How do you find those values? You plug in 0 for y to find the x-intercept, you plug in 0 for x to find the y-intercept, or you simply look at a graph if you're given and identify where it is crossing those axes. Then we talked about intersections of graphs, so having 2, or it could be 3 or 4 different equations and figuring out where they intersect, and you use similar methods that we used with a system of equations for linear functions. You set them equal to each other. You can use substitution or elimination, but you're determining the points at which these functions or graphs or equations, where they intersect. All of these ideas that we've been learning are really building into us better understanding how a function behaves so that we can do more with it and build on that in calculus. So go ahead and post any questions you have below, or write them down and ask me when you see me. I look forward to supporting you on this. Thanks for listening.